Okay, hello again. This is the questions and answers on atomic structure. I hope that you have tried them before looking at the answers. Let us go through the answers very quickly. Okay, the first question says the table shows the structure of different atoms and ions, and he asks you to get what is W, X, Y, and Z. Okay, how do we get W? He's asking for W, which is number of neutrons of magnesium. How do we get the number of neutrons? We said the number of neutrons is the difference between the nuclear number and the proton number. So 24 minus 12, that is 12. And that means that W is 12. That means that my answer is either C or D. Okay, what is X? X is the proton number of magnesium. If he says number of protons, later in the table, number of protons is 12. That means that the proton number also is 12. And that means that X is 12. So that means that my answer must be D. But let's go through the rest to make sure that everything is correct. Now, what's Y? Y is the number of neutrons for fluorine. And we said the number of neutrons is the difference between the nuclear number and the proton number. So 19 minus 9 is 10. So Y is 10. Z is the number of electrons for F minus. Now F already has number of protons is 9. That means its original number of electrons also is 9. But this is F minus. That means it has an extra electron, and that means that the electrons are 10. So the answer is D. Okay? Were you able to get that? Okay, let's move on. Which diagram shows the structure of an isotope of this atom? What is isotope? We said isotope is the same number of protons but different number of neutrons. So I'm looking for something that has the same number of positives but different number of neutrons. So the answer must be A. What is the electronic structure of an atom with a proton number 5 and a nuclear number 11? Okay. To determine the number of electrons is the same as the proton number. So it is the 5 that I'm trying to distribute. How is it distributed? It's distributed 2, then 3. So my answer is C. Okay, which number in the table is minus 1? So which one is minus 1? The one that has a negative charge is the electron. So my answer must be A. Which row gives the outer electronic shell of fluorine and neon? Remember, this kind of question can either ask you for the outer electronic shell or the total number of electrons. Now, here is asking for the outer electronic shell. That means the number of electrons in the outer shell. So, fluorine, if he says that already, I don't even have to look at the periodic table. The fluorine, he already tells me it's 9, atomic number 9. That means it originally has 9 electrons. How do I distribute them? The first shell takes 2, and then I'm left with 7, and that means my outer electron shell has 7. Now, neon has 10 electrons. How are they distributed? They're distributed 2 and then 8. That means the outer electron shell has 8, and that means my answer is A. Okay, which numbers are added to give the nuclear number of an ion? Now, the nuclear number of anything, whether it's an ion or an atom, is the total number of protons plus neutrons. So, number of protons plus neutrons, so my answer is D. Which atom has twice as many neutrons as protons? Now, remember that he's asking for number of neutrons, number of protons, and he wants something in which the neutrons are twice the protons. So actually you need to sit down and calculate how many protons and how many neutrons in each of them. Now, how many protons? The protons is a small number, and that means the first one is 1, 1, 1, and 2. These are the number of protons. So what about the number of neutrons? You remember that number of neutrons is the difference between the big number and the small number. So this first one doesn't have any neutrons. Second one has only 1 neutron, 2 neutrons, and 2 neutrons. So which one has neutrons twice as the protons? That is C. Can you see that? Okay, the table shows the number of particles present in the nuclei of 4 atoms, which 2 particles belong to the same element. How do I determine the same element? Remember that we said the proton number is the one that identifies the element. So if they are the same element, they must have the same number of protons, and that means that it is 2 and 3. What are the nucleon numbers of carbon and magnesium? Here he is asking for what? He's asking for nucleon numbers. The nucleon numbers means I look at the periodic table and I choose which number? The big one. So the nucleon number, if you look at the periodic table, carbon has a big number or a nucleon number of 12 and magnesium is 24. Carbon has 6 and 12. So the nucleon numbers are 12 and 24. Okay. The symbols of 2 atoms may be written as this. Which statement about these 2 atoms is correct? Let's take them one by one and determine which one is correct. Are they different elements or are they isotopes? That's my first choice. Now, if the small number is different, we said the small number is the atomic number of protons. If they are different elements, they will have different number of protons. So, since they have different small numbers, these are different elements. They're not isotopes of the same element, they're different elements. So my answer is A or B. Okay, why did we say they are different elements? Because they have different number of protons, right? Okay, students are asked to draw a diagram of an atom with symbol this. Which diagram is correct? Now, from this symbol, how many protons and how many neutrons does this element have? The small number is 1, and that means it has 1 proton. The big number is 3, and that means the total number of nucleons, or the total number of particles in the nucleus, is 3. That means if it has 1 proton, it must have 2 neutrons. So that is A. Okay, the diagram shows the structure of an atom of an element. What is this element? Now, we said what determines the element? The number of protons is the one that determines the element. So if he says I have 5 protons, I look at the periodic table and I look for which one has what? Which one has the small number 5? And I find that it will be boron. Okay? The diagrams show 4 particles. Which 2 diagrams show atoms that are isotopes? Again, we said isotopes are what? They have to be same number of protons, different number of neutrons. So from the choices that he gives me, it is D. Okay? Okay. What do the nuclei in hydrogen molecules contain? The nucleus in anything contains protons and neutrons. But for hydrogen, you have to remember that hydrogen has a small number 1 and a big number 1. That means the atomic number is equal to the nucleon number, and that means actually it doesn't have any neutrons. So the nucleus of a hydrogen has protons only. It's the only atom in the periodic table that has no neutrons at all. Okay, which statement about this element is correct? So, he gives me an element with a small number 81 and a big number 201. Let's take them one by one. The first one says this isotope has a nucleon number of 120. Nucleon number is the big number. So actually this has a nucleon number of 201, not 120. The number of electrons in one atom of this isotope is 81. Yes, actually, because 81 is the small number, and that is the number of electrons and the number of protons. The number of neutrons, okay, the number of neutrons, so actually so far B is the correct one. But let's take a look at the others to make sure that we're correct. So when you're choosing from the multiple choice questions, which are the questions in paper 2, when you choose something that is correct, please make sure that the rest are actually wrong, so that you make sure that your answer is correct. The number of neutrons in one atom of this isotope is 201. No, 201 is not the number of neutrons. 201 is actually protons plus neutrons. So that is wrong. So he's saying this is an isotope of that. No, it's not, because they have different number of protons. So that means that yes, my answer was B. Okay, what is the composition of the phosphide ion? And he gives you the formula of the phosphide ion. This is something that has an atomic number of 15, and that means it has 15 protons, 15 electrons at the beginning as an atom. But because it has 3 minus, that means the number of electrons is what? Number of electrons is 18. So I'm looking for something that has 15 protons. Number of neutrons would be 32 minus the 15, which is 17. And the number of electrons has to be 15, plus the extra 3, so that is 18. Okay, 2 isotopes of helium are this. Which 2 diagrams show the arrangement of particles in these 2 isotopes? Now we're looking for 2 diagrams in which both of them have 2 protons. And the first one has only 1 neutron, the second one has 2 neutrons. So my answer is C. Okay, in which species are the number of electrons and neutrons equal? Again, for this kind of question, calculate how many electrons and how many neutrons. So, how many electrons? That's 4. Remember that the electrons is equal to the atomic number if there is no positive or negative. Okay, so the second choice has 9. The third choice has how many electrons? It's supposed to have 11, but actually because it has a positive charge, that means it has lost an electron, and that means now that has 10 electrons. What about that last one? That last one has an atomic number of 8, and that means it originally had 8 electrons, but then it has a 2 minus. That means it took extra 2 electrons, and that means the number of electrons is 10. Okay, so, and then the number of neutrons is just the big one minus the small one. So this one has 5, 10, 12, and 10. So which of these has the number of electrons and neutrons equal? That's the last one, right? You cannot just choose anything by just looking at it. You have to think about the question before you choose just any random answer. Okay, X and Y are isotopes of the same element. Which statement is correct? We said if they are isotopes. Now, that means, let's take the choices. X and Y have atoms of different number of electron shells? No, actually, because they will have the same atomic number, the same number of protons, same number of electrons, so same number of shells. So, choice B, X and Y have atoms with the same nucleon number? No. That is the definition of isotopes. They should have the same atomic number, but different nucleon numbers. X and Y have atoms with the same number of outer shell electrons? Yes, that is correct. They always have the same number of outer shell electrons. X and Y have different chemical properties? No, because isotopes, since they have the same number of electrons in the outer shell, which determines the chemical properties, then they will have the same number of the same chemical properties. So my answer here was C. Do we understand that? Okay. Aluminium ion, aluminium 3+, has the same electronic structure as an atom of which noble gas? So I look at aluminium. In the periodic table, aluminium has an atomic number of 13. That means it originally had 13 electrons. If it has 3 positives on it, that means it has lost 3 of its electrons. That means it has 10 electrons. So when you look at the periodic table, the one that has the noble gas that has this electronic structure is just the noble gas right before aluminium. So if you look at the periodic table, it is neon, okay? So neon has 10 electrons, aluminium is 13, but it has lost 3. Okay? Which statement explains why isotopes of an element have the same chemical properties? Please remember that chemical properties are determined by number of electrons in outer shell. So the reason that any 2 elements will have the same chemical properties is if they have the same number of electrons in outer shell. So this applies also to isotopes. Okay, number of particles in the atoms are shown. Which statement is correct? Let's take them one by one again. W and X are isotopes of carbon. Is that right or wrong? W and X are both things that have 6 protons. If you look at the periodic table, it is 6. So this is the correct answer. Since they have, of course, they have the same number of protons but different number of neutrons. The others will be wrong. X and Y are isotopes of nitrogen. That's not right. X and Y are different elements because they have different number of protons. X has a mass number of 12. A mass number is the number of protons plus neutrons. So 12 is not the correct one. 6 plus 7 is 13. Z has an atomic number of 8, which is Z. Okay, Z, atomic number 8, that's wrong because atomic number is the number of protons. So actually the atomic number of Z is 7, not 8. Okay, now let's go into questions that are from paper 4. The table gives the composition of 3 particles. What is the evidence in the table for each of the following? So if we say a particle is an atom, we say it's an atom. Why? We said something is an atom because number of protons is equal to number of electrons. If the number of protons is not equal to number of electrons, then it's not an atom, it is an ion. Okay? They are all particles of the same element. Now, why would we say that they're all particles of the same element? Because they all have the same number of protons, or the same proton number. We said the proton number is the one that identifies the element. Particle B is a negative ion. Let's take a look at B. B, how do we know if something is a negative ion? We said a negative ion is the one that has what? It has more electrons than protons. So the number of negatively charged electrons is more than the number of positively charged protons. Okay? Why are particle A and C isotopes? We said if they are isotopes, then they must have same number of protons and different number of neutrons, and that is correct for this case. What is the electronic structure of particle A? Now, if you look at particle A, we said it has 15 protons, and that means it is distributed 2, 8, 5. Okay, this was the other question. Use your copy of the periodic table to help you complete the table below. Remember again that at the end of each paper, you will have a copy of the periodic table available to you. So, let's take a look at cobalt. Both of these particles are cobalt, so we look at the small number and the big number for cobalt, and we find that the cobalt has an atomic number of and a mass number of 59. So how many protons? It's the 27. For both of the cobalts, any cobalt will have proton number 27. Okay, number of neutrons is the difference between the big one and the small one. So 59 minus 27, that's 32 in both cases. Okay, how many electrons now? The first one is an atom, so it will have electrons the same number as protons. But the second one has 2 positives on it. 2 positives means it has lost 2 of its electrons, so now it has 25. Explain the term isotope. Please learn definitions. It's very important. Isotope is what? Atoms of the same element, having the same number of protons but different number of neutrons. Explain why 2 isotopes of the same element have identical chemical properties. Remember that we said chemical properties are determined by the number of electrons in outer shell, so any isotopes of the same element would have the same number of electrons in outer shell. State 1 industrial use and 1 medical use of radioactive isotopes. Remember that we said industrial use, uranium-235 to produce energy in nuclear power stations. Medical use, we said cobalt-60 for cancer treatment. Please identify the isotope and its use, not just the use. Okay, a radioactive isotope of iodine is used to treat cancer. How many protons, electrons, and neutrons are there in one atom of this iodine? So he gives me a small number 53 and a big number 131. That means the atomic number or number of protons is 53. The number of electrons is the same, 53, and the number of neutrons is the difference between them. When this isotope emits radiation, a different element with a proton number of 54 is formed. So he's telling me that now I have a proton number of 54, so I look at the periodic table, which one has a small number of 54, and I find that it is xenon. Okay? Okay, let's try to fill out this table. He wants me to write the symbol and the atomic number and the mass number. So let's take a look at particle B. Now, particle B, what determines the symbol? It's the number of protons. So I need to look at the periodic table and find out what is the number of protons. Which one has 19 protons? So potassium is the one that has 19 protons. The nucleon number, the big number, is the total of the protons and neutrons. So 19 plus 20, that's 39. Now, why did I put a positive on the potassium? Because the number of electrons are missing 1. They were supposed to be 19, but obviously this has lost an electron. If it loses an electron, that means it has an extra positive. So let's try and do C. Now, number of protons, again, I look at the periodic table. Which one has a small number of 30? I find that it is zinc. The number of neutrons plus the number of protons will give me the big number. And the number of electrons are the same as the protons, so I don't have any positive or negative on the zinc. Okay? Particle D, number of protons is 8. So I look for which one has a small number 8, and I find that that's oxygen. And the mass number is the total of protons and neutrons, so 8 plus 8 is 16. Now this one has 10 electrons. 10 electrons means it has gained 2 electrons extra to the original 8, and that means it has a 2 negative on it. Okay? Last one there, we have number of protons is 31, and number of electrons is the same. That means I don't have any positive or negative. I look at the periodic table and find which one has number of protons 31, and I find it's gallium. And the mass number is the 39 plus 31, so that is 70. Good so far? Okay. Using the data in the table, explain how you can determine whether a particle is an atom, negative ion, or positive ion. Again, remember, how do we determine if something is an atom, negative ion, or positive ion? An atom will have equal numbers of protons and electrons. A negative ion has more electrons than protons, and a positive ion has less electrons than protons. Okay? Okay. The other question. He's talking about zirconium, and he gives me 3 isotopes of zirconium. In terms of the numbers of electrons, neutrons, and protons, how are these 3 atoms the same, and how are they different? So they're the same because they have the same what? They would have the same number of protons and the same number of electrons. But because they are isotopes, they will have different number of neutrons. Isotopes have the same chemical properties because they have the same, again, I'm reminding you, they have the same chemical properties because they have the same number of electrons in outer shell. That is what determines the chemical properties of any atom. Okay, so that's the end of the questions. I hope that you got all of them correct, or you understood anything that you got wrong, and we'll meet in the next chapter.